Hello friends, in continuation with the last lecture, today we are going to talk about the next topic, that is errors in the measurement. Right, basis of the all the scientific studies or the research is nothing but the measurement. So whenever we try to do any kind of the research, then obviously the main thing we must do is nothing but the measurement of that physical quantity. So when we try to measure something, obviously there is the natural process to occur errors in that particular measurement of the particular physical quantity. So, whenever we try to measure something, that measurement are approximate values which are given within or the shown by the instrument within the limitations of the measuring device, environment, process, and the human errors. So all these things are included while trying to measure some quantity. The important aspect of this reporting or the measuring the any kind of the measurement is nothing but the consistency, then systematic, and revealing the context of accuracy and the precision. So these are very much important uh, terminologies of doing the any kind of the measure, that is the accuracy and the precision. Though are they related with each other, we have seen on the last lecture as well, but they are not the one and the same. So the main thing we must do in the or keep in mind in the measure while doing the measurement is nothing but the consistency and the systematic way how we can measure it. An error in basic quantities actually propagates through the mathematical formula, and that will lead us to how the compounding of the errors, and obviously at the end we will misinterpret the physical significance of the major data. We get the wrong interpretation of the whatever we are trying to do the measurement for. That scientific research will come with the wrong conclusion at the end. So the errors are actually broadly classified into the two categories. The first one is the systematic errors, and the another one is random errors. So let's see one by one in detail. So systematic error, these errors are result due to the faulty measurement practices. If we are doing the faulty measurement calculation, in the sense that the wrong way we are trying to measure the that measurement, then obviously this errors will occur in the measurements. And these errors are characterized by the deviation in one direction from the true value. If we are started in the wrong direction, obviously we'll go in the same direction, and at the end we'll be getting the wrong information regarding it. So it will deviate from the true value. We deviated from the its true value in one particular direction. If we are in the negative direction, we'll go in the same direction. If we are in the positive or higher values, we'll go in the same direction as well. Uh, Systematic errors impacts the accuracy of the measurement, not the precision of the measurement. See, the thing is that here we will be or these systematic errors impact on the accuracy of the measurement, not the precision one, because precision is related to the instrument. These errors result from the faulty instruments, wrong measuring process, and the personal biases. Right. So we are means personal biases, that the human introduces the errors in this measurement. So or else the wrong measuring processes. If the operator does not know how to measure the physical quantity, then obviously this will give us the systematic error in the measurement. These types of errors cannot be minimized or reduced by the repeated measurements. If we are following the wrong process, obviously these errors will not be minimized. And so these errors cannot be minimized either of the way, even if we change the instrument or else. Okay, so yeah, even if we have the repeated measurements of the same physical quantity by the same operator. For example, the faulty machine does not improve the accuracy of the measurement by the repeating measurement. If the instrument itself is a faulty one, then how will it come give us the correct, the accurate measurement or the accurate result out of it, even if we repeatedly do the measurement on it. Then next is nothing but the random error. So it is not a unidirectional error, unlike systematic errors. Those are the unidirectional or the one-dimensional, one-directional error occurs in the measurement. Uh, some of the measured values are the greater than the true value, or some are the less one. So it can just go above the or overestimation of the value, or else the underestimation of the value. We can have both type of the values we can get after the measurement. So the sum of the measured values are greater than the true value or expected value. Some are less than this. The errors which are introduced here, or these random errors are introduced, are sometimes the positive or the negative values with respect to the true value. It is possible to minimize this type of the error by mathematical formula and repeated measurement. So how we can do it? It is possible to minimize this type of error, but how we can minimize them? By the mathematical formulation and repeated measurements. Let's try to repeat the measurement number of times and take out the average, then we can minimize such type of the error in the measurement. Okay. It is not the biased error, just like the systematic errors, which is biased, depends upon the person who is trying to measure the physical quantity. These errors are because of the limitations of the instrument and limitations on the part of the human ability. Means that depends upon the operator who is operating the that instrument. Limitations on the part of the human ability, because uh, no human can repeat an action in exactly same way or the same manner on same method measure it repeated. Means if we cannot repeat the same procedure in the same manner, or our actions cannot be same every time. So this will introduce the random measurement. Then the next error is, or type of the error is instrumental error, and these type of the errors are something like we can say the zero error is an example of the instrumental error, which is introduced in a measurement consistently in the one direction. Zero error, it is actually the pointer is not at the zero when before we start the measurement. So the zero error results when the zero mark of the scale bar does not match with the pointer. Okay, so the pointer is not exactly at the same at the zero. For example of this is in the vernier caliper, the 9 divisions on the main scale should be exactly equal to the 10 divisions on the vernier scale. So this you could have seen in the vernier caliper experiment in the last year, right? So the 9 divisions on the main scale should be exactly matching equal to the 10 divisions on the vernier scale, so that we can get the we can have the instrumental error in this, yes, if it is not matching. These errors occur because of the faulty design of the instrument, because these errors are because of the faulty instrument. Means the instrument has itself some fault within it in its design, so these errors occur, and these errors can be minimized by the replacing the instrument or the change in the design of the instrument. So, but for that case, we must understand that okay, instrument itself is faulty. The last error in the measurement is the procedural error. The faulty measuring process include the inappropriate physical environment, procedural mistakes, and lack of understanding of the process. So the faulty measuring processes, actually the person who is measuring does not know the how to do the measurement, and in means inappropriate physical environment. Something like some measurements has to be made in the constant temperature surrounding, and if the surrounding temperature is varying, then obviously this will not give us the similar kind of the results. Or the procedural mistakes while trying to follow the one protocol, so we are just jumping from the one to the other one, randomly, then this will introduce the errors in the measurements. We call it as a procedural error, and the lack of understanding of the process. The person who is using the instrument has the uh, least knowledge of the processes. For example, if we are studying the magnetic effect of current, then it would be erroneous to conduct the experiment in the place where the strong currents are flowing nearby. So we should do the or what we can say, we should avoid the uh, magnetic measurement where the strong current flowing devices are nearby, which are placed in the nearby the its instrument. These type of the errors can be minimized by the periodic assessment of measurement process. Okay, this can be how we can minimize periodic assessment process of the measurement process, and improvising the system in consultation with the subject expert. If we do understand that there is errors in the measurements, obviously we can just consult with the subject expertise, or we can follow them. We can again go back to the protocols given, or SOPs which is given with the instrument. A personal bias is introduced by the human habits which are not conductive or for the accurate measurement. So the personal bias is introduced by our human, and this actually we can understand from this example. The reading habit of the person. So as means the reading habits of the every person can't be the same. So this will introduce the errors in the measurement. Something like just the person who is reading may have the habit of reading the scales from an inappropriate distance from an oblique direction. So while trying to measure the read the readings on the uh, meter scale bars, then we should on the pointer one we should look from the exactly from the upside, so that oblique direction will not introduce the errors in the measurement. The measurement therefore introduce the errors on account of the parallax as well. Okay, so that we should avoid the this type of error, that is parallax errors include on account of the parallax angle. So the direction in which we are just trying to look at the meter, that should be from the top, okay, with the flat we should look. So this will introduce the procedural errors in the measurement. So herein uh, uh, ends the theory part of the first chapter, that is fundamentals of measurement. Thank you.